Okay, welcome to the notes on 5.4 direct variation and direct proportion. Okay, first off, direct variation, we're going to go ahead and define this part of it. Direct variation is a relationship between two variables where one variable y is directly proportional to another. So they're going to be throwing in some key phrases in here. Is directly proportional to another variable x, meaning that y is equal to a constant k multiplied by x. So this gives us our first formula that we're going to use today. So y is equal to k times x. Now direct proportion is a relationship between two variables where they increase or decrease in such a way that their ratio remains constant. Okay, relationship between two variables where they increase or decrease in such a way that their ratio remains constant. So we're looking for our k value in that case then. And so what we're looking at is if y and x are directly proportional, then the following statement can be used. K is equal to y divided by x, where k is your constant of proportionality. Okay. Now, the difference between direct variation versus direct proportion is not much. Direct variation is often used in algebra and calculus, where we're going to see key phrases, very generic statements like y varies directly with x. Okay. It's the way we describe the mathematical relationship where one quantity changes as a direct multiple of another. So it's where one quantity changes as a direct multiple of another. Okay. Now, direct proportion is often used in real life contexts such as physics, economics, and science. For example, Newton's second law of motion. So you do not need to memorize this unless you're going into a science field here, but it's one that's very simple to remember. It's force equals mass times acceleration. Okay, where mass is m, acceleration is a, and force is f. So we have force is directly proportional to mass and acceleration, meaning we're multiplying. So this is multiply. Okay. As far as graphs go, whether you're looking at a graph of a linear function or whether you're looking at a direct variation or direct proportion, it wouldn't matter because they produce the actual same graph pretty much. The key characteristic that we're looking at is the graph is a straight line that passes through the origin. Okay. Now, for this one here, we'll go ahead and trace over a line. We have a linear function that's passing through the origin. So we're going to go ahead and make our point through the origin here. And this is any function that's linear that passes through the origin can be determined that it's a direct variation. Now, another part that it didn't include on these notes is what about functions themselves? So how can I tell a dv function? Well, dv functions look like the following. We'll have y equals x, y is equal to 2x, y is equal to 1/3 x, anything like that. What you should see is that there is no b value in the equation. Okay, so it's literally like saying plus 0, plus 0, plus 0. Okay, or adding 0, since the 0 is the y-intercept. Functions that are non-direct variation is when you have any y-intercept other than 0. So for example, y is equal to x plus 1. Y is equal to 2x plus 1. Y is equal to 1/3 x plus 2. Let's do a different value there. What we're going to see is that I have a b value that's not 0. So b value not 0. Okay, now as far as tables go, tables are pretty quick. If you needed to check to see if the table is direct variation, all you have to do is take y divided by x. So we'll take our xy table, we'll create a third column. And what we're going to do is we're going to check the ratio of y divided by x to see if it's the same for each set of points. So the first point, 1, 3, we're going to check the ratio of that as y divided by x, or in other words, 3. 3 divided by 1 gives us 3. 6 divided by 2 gives us 3. 9 divided by 3 gives us 3. 12 divided by 4 gives us 3. So the pattern here is that k is constant. Therefore, direct variation exists. So we can actually say that y varies directly with x. Now, in the second table over here, we have our xy again. We're going to check to see if the k's are the same. And what we do is, again, do the same thing. Y divided by x. 3 divided by 1, that gives us 3. 5 divided by 2 gives us 2.5. 7 divided by 3 gives us 2 point repeating 3. And then 9 divided by 4 gives us 2.25. And so you'll see that k is not constant in this problem here. So k is not constant. Therefore, no direct variation. This means we will have a y-intercept that is not 0.